What's happening, dogs? Mr. Allen here. We're about to use Pascal's triangle to expand this binomial a plus b quantity cube. So the first thing I want to do is jot down those first few rows of Pascal's triangle. And if you remember correctly, adding the previous 2 gets you that next guy right there. It always starts with 1, then 1 plus 2 gives me 3. Then I got 3 and 1. Look at that. We already have the line we need that goes for a binomial raised to the 3rd power. That 3 tells us it goes with that. How convenient. How convenient. Thank you, Mr. Pascal. All right, it might have been doctor. I don't know. Anywho, all right, so these numbers here help us get our coefficients. It's not always that number, because if I have any coefficients within that binomial, then things change, but we'll deal with that another time. All right, baby steps. Let's start with the basics here. The basics. Okay, so let's keep going here. So what I'm going to have here is I'm going to lay out the 1, 3, 3, and 1, and I'm going to leave some space. So I have 1, 3, 3, and 1. Then I'm going to work with my first term of this binomial. So that a right there. It starts as a cubed right up top. Then I got a to the second. I'm going to work my way down. Then a to the first. Then a to the 0. 3, 2, 1, 0. America. All right. B starts with 0. So b to the 0 power. Then b to the first. Then b to the second. And b to the 3rd. Now, since everything is positive here, these are all going to be positive as well. When we start getting a difference of those 2 terms, or maybe I have a negative in the first one, things change. Again, basics first, baby steps. Let's keep going. All right, let's simplify. 1 doesn't really matter. B to the 0 is just 1. So I just have a cubed for this first one here, right? Dope. Next one, I have 3a squared b, so we'll write it as 3a squared b. No one writes it to the first power. That's kind of weird. Don't do that, okay? It's not wrong. It's just a little weird, all right? Then we got 3ab squared, and then we have 1 times b to the 3rd. So b to the 3rd, boom. There's our answer, man. Dang, that was dope. Super dope. Okay. Now, I'm feeling, feisty here with the math. What if we wanted to do, how about let's go with like 2a plus b raised to the, how about 4th power? Okay, let's go one more line. Let's go one more line, shall we? We shall. All right, so I'm going to write one more line of Pascal's here. We got 1 first, then we have 1 plus 3 is 4. 3 plus 3 is 6. Then we got 4 and 1. Woo! Dang! That is dope. So those right there are going to help me with my coefficients. But it's not necessarily my coefficient, because that 2 is going to throw a wrench in the chain here. All right, so let's write this out. I've got 1, I've got 4, I've got 6, giving myself some nice space, 4, and 1. Beautiful. Okay. Now the next thing here, I got to deal with this 2a raised to the 4th. The whole 2a raised to the 4th. The whole 2a raised to the 3rd. And then once again to the 2nd, to the 1st, woo, and then to the 0. Dang, that's dope. Now, with the b, you guessed it, 0, 1, 2, 3, 4. Boom. Woo! That is an ugly mess right there. There is so much happening. We got to simplify this thing out. But again, the organization is key. One after the next. Woo! Man. All right, let's keep going. So I've got, let's see here, 1 times 2a to the 4th. Well, what's 2 to the 4th power? That's 16. Remember, b to the 0 is just 1. So we're going to have 16, because that 1 there is not going to do anything either. We're going to have 16a to the 4th. Next one, we got 2a cubed. Well, 2 cubed is 8, right? 8 times 4 is going to be 32. So we got 32a cubed b to the 1st. Just leave it as b, right? Don't want to be weird, man. Okay. Next one. 2 squared is 4. 4 times 6 is 24. So that's going to be 24. We'll have a squared, b squared. Okay. Next one. We have 2 to the 1st. So that's just 2 times 4 is 8. Then we have a. We have b cubed. And then the last one, we have 2a to the 0. That's just 1. Then we got that 1. We got b to the 4th. So plus b to the 4th. No coefficient on that one. Dang, dog. That is dope. It's pretty awesome, man. It's pretty awesome. I never circled my answer on this one here. And now I want to circle this one too. That's exciting. That's exciting. All right, there we go, guys. 2 examples on Pascal's triangle, right? 1 with a coefficient in that binomial, because that does change things up as you see with those coefficients. But the 1, the 4, 6, 4, 1... Stay organized, one term at a time, then go to your next variable each term, and then that, and then it does the pattern, man. It does it awesome. It's awesome, just like you guys, and I hope you enjoyed Pascal's triangle expanding of binomials as much as I did. Clearly, I loved it. Have a great one, guys.